Hello and welcome to this UK Data Service webinar on data management basics. Your trainers today are myself, Scott, and my colleague Kate. We are from the Research Data Management team and we provide guidance, training and support on data management. The structure of this webinar is a 40-minute presentation and then a 20-minute section at the end for any questions you may have. The slides from this webinar will be placed online on our website after the webinar, so you can utilise all the links and resources within them. Okay, so an overview of this session. So we're going to begin just by identifying who the UK Data Service are and what we do, and then we're going to go into managing your data, a little bit about background, why and how, and then we're going to look at some specific topics. So these topics will be consent, anonymisation, documentation. We'll also look at security, backups, encryption and cloud storage. Now throughout this we've already had a few questions asked around the GDPR, which is the General Data Protection Regulation, which is coming into force on the 25th of May 2018. So we'll be sort of making little notes towards this, but there's still a lot going on in development in this area, so we can't provide detailed advice at the moment, but there will be further guidance coming up obviously in the coming months. Then we'll move on to some more resources because this webinar is really just a highlights only reel. And then we'll have the time, as I said, at the end for any questions you may have that we can try to answer. So let's begin with a little bit about the UK Data Service. So the UK Data Service is funded by the ESRC, so the Economic Social Research Council, and is a single point of access to a wide range of secondary social science data. And we provide support and training for data creators with accessing, managing, sharing and using data. This is delivered by staff based at various universities across the UK, including Essex, Manchester, Leeds, Southampton, Edinburgh and UCL. Now the UK Data Archive manages the UK Data Service and curates the data. And there's some links on here, so if you wanted to look at our Data Discover catalogue, there's a link directly to that. And there's also various other webinars that we provide, and I've provided a link straight there so you can jump through to them as well. So a little bit of background about data sharing. So what we're finding now is that data sharing is actually becoming very important across all sort of disciplines and provides a variety of benefits, not just to the individual researchers, but also the institutes, the funders and the general public at large. Now, good research data management habits are actually essential to ensure that the data which are created at the end of a research project are actually suitable for sharing and reuse by others. And what we're finding now is that many funders and academic publishers are requiring data sharing and also specifying their own requirements around data handling, including the formation of something called a data management plan. Why is it important then to manage research data well? Well, to begin with, data creation itself is often quite expensive, both in terms of the money that is put into the research project, but also the researcher's time. So it's important to have this clearly structured and enabling the reuse so that others can use that data and not have to go through the same process of creating it. Data itself is the cornerstone of research, and it's hoped that good quality data should lead to good quality research. And data underpins all of the published findings from research, so ensuring that others can access this and look at it and reuse it is very important. It also ensures that we have compliance with ethical codes, the data protection laws, journal requirements and also funder policies. And it's also key to ensure that we protect this data from loss, destruction and potential exposure, whether that may be accidental or deliberate. So what are some practical steps that we can take? So some of these things are going to be really simple to do, but they actually allow the data at the end to be shared. So the first thing is actually writing a data management plan or a sharing plan. This helps you decide how the research data will be managed throughout the research lifecycle itself, but also how it can be deposited at the end of the research. Now, to make sure data are shareable and can be easily understood and used, it's very important that when you're collecting the data, the correct consent is gained, particularly for sharing the data at the end of the research project, and that we don't disclose identities of participants without their consent, and that we use things such as open and standard formats, and provide good contextual and documentational information with the data, and that the data is actually protected at all stages of the research lifecycle, whilst it's being collected, whilst it's being analysed, and then whilst it's being deposited at the end. So what we're going to look at now is a data management plan, which is something I talked about earlier. And the one we're going to use here as an example is an ESRC data management plan. And each funders may be slightly different, but they typically cover a similar array of categories. So the ESRC data management plan has 9 sections to it. So it involves you as a researcher beginning by making an assessment of the existing data which is already out there, which may be deposited with ourselves or other archives, and then looking at the information on new data, so the data that you propose to create and collect. And then we look at the quality assurance of that data, how you ensure that it's good quality data, the checks you will make as you're collecting the data, and then how you plan to back up and securely store that data. And one of the most important sections from our point of view as an archive is any difficulties you feel you may have with data sharing, and then the measures you will put in place to try and overcome these. And here we can look at specific strategies such as consent, anonymization, and other reuse strategies. It's also important that the data management plan considers things like copyright and intellectual property ownership, particularly if we're talking about interviews or if you're using data from other sources, and then about assigning responsibilities to people within the team and who's going to be responsible for the data protection and management throughout, and then management and curation of the data. This document should be seen as not something that you create just as a one-off at the beginning of a project, but something which we like to think of as a living document, so it's updated regularly and can be changed and takes into factors which you may not have considered in the first instance, but as you're progressing through your research project you then identify, say that be that you find that you're not able to get the consent you planned on, can you use anonymization to address this, or does another policy or something have to be put in place? So I mentioned these sort of tools for protecting participants, and there are a variety of ways to do this to ensure you comply with your legal and also your ethical obligations. So there's 3 we're going to look at today. So one is around seeking informed consent, and this is specifically in our context for data sharing and the long-term preservation and curation of that data and for its publication in a repository or an archive. And then the second is looking at protecting identities through things such as anonymization and perhaps not collecting personal data which is only needed for administrative purposes. And the third is called access regulation, where we look at the possibility of having control or some form of access controls placed upon the data, whether that be for a group or a use or a time period. So let's explore these in a little bit more detail. So when we talk about informed consent, consent itself for sharing should be seen as just one more sort of small step. So as researchers, we're all already very good at ensuring that we gain consent for sharing in the research process. So i.e. when we involve participants in a project, we explain what's going to be involved in partaking in the project on their behalf. And we also ensure we gain their consent for any dissemination of that information through whether it be presentations, publications, or on the web, or for using quotes or videos or photos in articles or for publicity. So what we need to do on top of that is just add this one more small step, which is just ensuring we gain this informed consent for data sharing and archiving. And to do this, it's important to consider the potential future reuses of the data and where it may be stored, so the participant can then make an informed decision themselves whether they wish to consent for their data to be deposited in a repository. And it's absolutely fine if they don't, but it's about empowering the participant to have that opportunity to make the decision and not ourselves doing it or not having that informed consent to know about it. However, as always, consent, it's dependent on the research context, and there are certain cases, there may be special cases where covert research is being undertaken, or we may be talking about verbal consent, and so they need to be factored in as well. So now let's have a little look at what this can mean in practice. So here we have a couple of example statements which you could include on a sort of information sheet or a consent form, and it provides the participants with some information. So if we look at the bottom one first, this is very much what I would talk about as granular consent. So it breaks the consent down to very specific parts of the data which have been collected. So you can see here that we inform the participants of where the data itself is going to be archived and what it will be then used for. So this will be for other research and learning purposes. And then the participant has the choice of selecting which parts they wish to be deposited, if any at all, with that archive. So for example, that might be just the audio recordings, or maybe they don't want the audio recordings but only the transcript, or none of it at all. If we look at the top one, this again gives, explains to participants how that data will be deposited at the end and asks for their consent, but it doesn't give that granular level that you get in the bottom box. And here we have another example. So the one on the right provides some information about protecting participants' anonymity, and also there's some information on the left-hand side talking about removing personal information, so that will be removed from the thing. Note that none of these guarantee absolute anonymity. In practice, this can be very hard to achieve, so statements like that should kind of be avoided to ensure that participants don't expect something which you can't actually achieve in practice. And at the bottom here, I've included a link which will link directly through to our website, and we've got various examples of consent forms which have been used by other projects which you might like to look at and see the way they've dealt with consent and that. So now we'll move on to the second category that I talked about, which was anonymisation, and this is going to be broken down into quantitative data and qualitative data. So we're going to start with the quantitative data, and here we talk about removing direct identifiers. So direct identifiers are things that lead to you basically directly being able to identify a participant. So for example, some of these things will be very simple. They'll be the names, the addresses, their institute, or perhaps photos. One of the other ways we can anonymise quantitative data is to reduce the precision or the detail of a variable through what's known as aggregation. So for example, rather than giving the full date of birth, we may give the year of birth, and rather than a specific job title, we may give an occupational category. And when we come to consider a village or a location of someone, we might say an area, a much more broader area rather than a specific village. We can also generalize the meaning of a detailed text variable, and we can restrict upper and lower ranges of variables to hide outliers. So when we think of income or age, so if we looked within a certain area, we may find that there's only a very few people that are over £150,000, so they may be able to be identified. So if we restrict that to above 100, that may make it easier to hide those outliers and make it more difficult to identify them. And we can also look to combine variables as well. So when it comes to qualitative data, we typically advise that you should plan or apply this editing at the time of transcription. There is an exception here when we talk about longitudinal studies, which is where you would anonymise the data later so you don't break the linkages. Some of the key things to think about here are avoiding this idea of blanking out, so getting a big black marker and blanking out massive parts of text. It's much better to use things such as pseudonyms or replacements, because if there's a big piece of blacked out text, you can't see what that is and understand it, whereas if you put in a different name or something like that, it makes it easier to then reuse the data. It's also important to try to get this balance of avoiding over-anonymisation, which can distort the data, as well as maintaining the anonymity of your participants, and that can be a very difficult balancing act to achieve in practice. Now on the website we have a useful case study where a qualitative researcher talks about the process they go through when they're trying to do this, and they kind of try to put themselves in the shoes of someone using the data, but also the participant as well, so what the participant would know and what the other user would know, to try and help them make these kind of decisions. It's also important to ensure, if you're on a sort of collaborative team project, that there is consistency across the research team when it comes to writing up the transcriptions and the way the data is anonymised. It's important as well when replacements are made, these are identified clearly with brackets around the text. And also an anonymisation log should be kept of all the changes and replacements and aggregations and removals that are made, but this must be kept separate from the anonymised data files, if not the whole point of anonymisation is kind of circumvented there. What about audio-visual data? So this is slightly different. So you can use digital manipulation on audio and image files to remove person identifiers. So we can use things such as voice alteration or image blurring of faces. But this is very labour intensive. Typically it's very expensive as well, and also then damages the research potential of the data. So here some better alternatives are seeking consent from the participants to share the data in the unaltered form itself for research purposes, and to try and ensure when you're collecting the data that you avoid discussing anything which is disclosive during the audio recordings. Obviously you can't always guarantee that, but where possible, if you can, that would be easier rather than trying to anonymise it. So let's have a look at a practice example of anonymisation here. So this is based on an interview transcript. As you can see on the left here, we've got an interview with Lucas Roberts. So this is the person's name. So this could be replaced with Ken. This removes the surname and there's a pseudonym. And for example, where it's the date of birth, we may just give the year of birth, so we take out the 2nd of May. And the location is quite specific there, it's Plumpton in North Cumbria. But we can remove Plumpton, and that just makes it more aggregated, more broad. And again, you can see other examples where that name has been changed throughout. So the third category I talked about was access controls to data. And here at the UK Data Archive, we actually have 3 categories of access control that we can apply to data. So we'll now go through these. So we have the first one, which is open, and this is basically available to download online to anyone, so that you don't have to register with the UK Data Service to access that information. You can just literally pop straight into Discover, find the information and download it. Then we have this second category, which is known as safeguarded, and within this category we have a couple of options available. So safeguarded data is available to download online once users have logged in and have registered and agreed to our end user license. And one of the terms within this end user license is that you won't identify or seek to identify any potentially identifiable individuals. If you do, you will be in breach of that license. Then we have these other 2 categories that I mentioned. So we have the special agreement, which can be known as sort of deposit of permission, or we have the embargo for a fixed period of time. So say, for example, if a researcher had deposited their data but was still working with the data on a publication, that data can be embargoed for, say, a 6-month to a year period. So what would happen is there'd be a metadata record of that information in our Discover catalogue, so others can see it, but they can't access the data until the end of that embargo period. So the other options, such as a special agreement, would be where the data is classified as more sensitive, and that to actually access the data, the user has to contact the depositor of the data and seek their permission first, explaining why they would wish to use this data and what they plan to do. If the depositor is happy for that, they then contact ourselves and we then release the data to that researcher for that purpose. The third and final category is for controlled data. So this is where there is likely to be personal data and it might be quite disclosive. So this is available through our remote or safe room access, and it's only available to authorised and authenticated users who have to undergo special training, a day's worth of training from our team who provide this, and their proposal is then vetted by the team as well to check that it meets our requirements and those of the depositor for releasing the data. And then when the data are used, this will then be passed again to a team to check any publications or any information you're looking to use to ensure that there's nothing in there that's being released which is disclosive. So let's have a look at what we can do with data access conditions in practice. So here I'm using again the example of the foot and mouth disease epidemic in North Cumbria. So we had various data here deposited with ourselves, and when it was originally deposited, the 40 interview and diary transcripts have been archived under a safeguarded access. So that's the second tier access, and that means basically as long as you register with ourselves you can access this information. When the data were originally deposited, 3 of the interviews and 5 of the diaries were actually embargoed, so that was under safeguarded but under the embargo, so no one could view them until the end of 2015. And this was because there was the participants didn't want that data being released until after 2015 because it was a very sensitive topic at the time, and there was some information in there which was disclosive to them, which they didn't want released at that point. And then we had some audio files which are archived as well, and these were placed under the safeguarded special agreement arrangement, where they're only available by permission only from the researchers. So you have to submit a proposal to them, and they then sign off on that, and then we can release them. So if you wanted to look at this record yourself, again, there's a link on the slides which you'll be able to click through, and there's also some data documentation, so a user guide which comes with this study, which you can take a look at. Okay, so that moves us nicely on to documenting your data, and this is another important consideration for ensuring that the data that you create are shareable as well as reusable. So when we think about documenting data, it enables us really to understand the data and how to use it when we ourselves return to it, or if someone else was to use it. And really what's important here is ensuring there's sufficient information for future researchers to understand the data itself and then be able to use it. So one way of thinking about this is to look at it from the point of view of someone who's coming to the data for the first time. So here you need to consider what would you as a new user need to know and make sense of that data which is in front of you. We're going to go through in a little bit more detail now some of the things you can do to help achieve this in practice. But before we do, I'll just explain how we use data documentation at the archive. So we use it to supplement a data collection to give further information. We also use it to ensure that the data itself is processed and archived accurately, and we use it in a catalogue record for when it's published so that others can find that data to then reuse it. So what kind of things can be included as documentation then? Well, anything really which would be useful to a future user to help them understand it. So things such as the methodology and the processes used, any sampling or sampling sizes, any protocols or interviewer instructions, the information sheet or consent form that was used within a project, any questionnaires, show cards or question lists, transcripts with contextual information such as the date, the place of the interview, interviewee names, etc. And then a data list can be very useful. So this is an overview of key information about each interview. So it's kind of an at-a-glance summary of the data collection. And any links to your own reports and publications that were produced from this, or any policy implications which came out. So let's think about variable names here. So all sort of structured tabular data should have records and variables adequately documented with names and descriptions. So what might these include? So these could include, for example, the question number, the system related to the questions in a survey, a numerical ordering system, and meaningful abbreviations or combinations of abbreviations. So I've given a few examples here, such as OZ%, which means percentage of ozone, GOR, government office region, and others. One thing to think about here when you do give variables is in certain disciplines they will mean very different things to what they do in your discipline. So again, it's about ensuring that you provide this after the abbreviation a meaningful label to it so that others can understand it, because they may interpret it as something else because it means something else in their discipline. And for interoperability across platforms, variable names should be no more than 8 characters and without spaces. I started mentioning sort of variable labels. What are these? So again, the aim is to be brief here, a maximum of 80 characters, and if a measurement is applicable, then include that unit of measurement. And this can include the reference to the question number or survey questionnaire. So there's an example here given on the screen. And it's also very important that if there's data missing, that there's a code for this given. So to try and avoid blanks or just 0 values. So for example, we might have a special number for the data not being recorded, or where no answer was provided, or if it wasn't applicable, or there was an error, or it wasn't known. And you can see some examples on the screen there. And there is coding of classification schemes used with bibliographic references, and there's a couple just listed there if you're interested in going away and researching them further. So let's have a little look at what this could mean in practice. So here on your screen, you should see this is from SPSS. So we're looking here, you've got the names on the left-hand side, and then you've got a label. So if you look at the first name, that's been given quali 10, and that as a name wouldn't mean very much, I doubt, to a researcher who wasn't on the project. But if we look at the label, it's quite clear here what that means. So it's which of the qualifications on this card do you have? And similarly, we can think down pay last. That might not mean too much. Does that mean the last payday? But if we look here, we can see that clearly means it was the year left last paid job. So again, it's very important to have this information so that others can reuse it, but also yourself if you come back to a project, because we work on multiple projects at a time often, and we may have to come back to some analysis 6 months later. Having these clearly listed labels will make a big difference to being able to go back to a project and understand what you've got there. Let's have a look. I mentioned earlier user guide and documentation. So this in practice include a variety of things. Again, it's all about providing this contextual information we think of. So this may include things like the interview schedule, transcription notes, or perhaps even photos from the project itself. And again, I mentioned a data list near the beginning, and this is an example of what a data list can look like. So again, it's an at-glance summary of the interview. So here you can see the respondent ID number, the population group, date of birth, gender, occupation, and a brief summary of the interview and the place of the interview itself. We mentioned transcription earlier. So what would be good to include on a transcription? It should include a unique identifier and ideally adopt a uniform layout throughout the whole research project and make use of speaker tags. Carry line breaks and be page numbered, and carry a document header giving brief details of the interview. So this may include information such as the date, the place, the interview name, interviewee, etc. Other things worth considering are a cover page, and if you're going to use computer-assisted qualitative data analysis software, whether this has compatibility and import features of whatever you're using. So again, here is a nice example, and you can see here clearly who the interviewee is and who the interviewer is. So if you look through, you can see there's a break between each line, so it's very clear. If the data was all together and this wasn't as clear, you could imagine seeing this as I came here in late 1968, then you came here in late 1968, all on one line. It would be unclear who was asking the question, who was answering. So having this broken up makes it a lot easier to then reuse this information if you're not fully adept with the project itself or weren't involved in the collection of it. Let's think about file formats now. So there's a choice obviously out there of software to use for data and file formats. So one of the things to think about when you're doing a data management plan is the cost of any software you may use, any hardware you may need to use for audio capture, and any discipline-specific standards and customs. But you also have to think about this potential danger of obsolescence of any software or hardware which is used. So how can we try to avoid these problems? Well, one of the best things to do is use formats which allow for long-term preservation. So these would be non-proprietary formats, so they're kind of standard and interchangeable and open formats. So these may be some examples on there are sort of open documents, rich text documents, PDFs, tab delimited. And we have quite a lot of guidance on what we at the UK Data Service recommend for this, and there's a link on the slide which you can click to. And I've also included the Digital Preservation Coalition's guidance on this as well, if you wish to explore that. How about organising data? Well, it's actually really important, particularly on collaborative research projects, to think about the way you organise the data. So here it sounds very simple, but using a logical structure is really important. So for example, we can use a hierarchical structure and group files and folders into very specific things, such as the audio transcripts and annotated transcripts. And we may put the survey data somewhere different and the interview transcripts as well. We need to think about the way we name files. So a lot of people use spaces. Is it better to use an underscore if we're going to upload the data online? Because if not, we get those annoying percentage things that come up when it's uploaded. And then how do we name files? So I'm sure we're all aware of the idea of we create a file, we might use some form of version control, so 1.0, 1.1, 1.2, etc. Major revisions go up to 2, minors are the little 1.1, 1.2s. But actually how we name the final version, we've all seen documents where they say the final presentation, final data or whatever. How do we know which is actually the final one, so using some kind of very clear structural and naming system would be good, so maybe only having the final as the final version. Let's now consider some data security and storage aspects. So it's really important when we think about the data that we protect it from unauthorized access, use, change, disclosure and destruction. Now we never know who's watching, listening or attempting to access your data, and that doesn't have to be governments, that can just be by chance people coming across it. And we need to think clearly how to protect it from these. So what we need is a data security strategy, and some of these tips are going to be very basic, but they're actually very important and regularly can be overlooked. So the first thing is thinking about controlling access to the computers where most of our data is typically stored on. So here, using strong passwords and locking our machine when we walk away from it is very important. It's very easy to leave an office to quickly go and do something and leave the computer unlocked. Just simply doing that then allows someone access to that data if they pop into the room. So just simply locking the computer is a really good way to avoid that problem. Running up-to-date antivirus and firewall protection again is important. And you can use things such as power surge protection in case the power fails on the building. Utilising encryption. This is a really useful tool to use to protect data, and that should be on all your devices, not just your desktop at work or your laptops and memory sticks and mobile devices. It should be your computers at home and any time you move these to travel. Where there is sensitive materials, these should be restricted access. So if they're on a computer, they should be in a restricted folder, or if they are on paper, they should be in a locked filing cabinet. And the thing to remember here is that personal data need more protection, so they should always be kept as securely and as separately as possible. Other data security strategy points are controlling access to buildings, rooms and file cabinets, and perhaps one of the most important things is ensuring that data and equipment is properly disposed of at the end of the project and destroyed correctly, and this is something we'll talk about later. So I mentioned encryption software. So encryption software now is actually incredibly easy to use, and it enables you as a user to encrypt a hard drive, a partition, specific files and folders, or a complete computer. You can do portable storage devices, and your phones and things can even be encrypted. So what we've got here are 4 of the more common encryption options that are out there. We don't make recommendations on encryption here at the UK Data Archive, but these are 4 programs which one could look at using. So let us start with BitLocker. So BitLocker is a proprietary system which comes as standard on selected editions of Windows, and it enables full encryption of the disk and volumes and USB drives. If your computer doesn't have it installed on it, if you don't have the correct edition, if you plug a drive in which does have this piece of software on it, or is a BitLocker drive, it will still allow you to unlock it. As long as it's a Windows computer, you'll have the option to do that. You just can't perform the original encryption. This is a proprietary piece of software, so that leaves some to question whether there may be a backdoor into it. And this goes for anything which is proprietary and not open. If we now look at Apple's version, which is FileVault 2, this comes standard now across all Apple Macs and devices, and this enables full disk encryption and allows you to encrypt a USB drive. Again, this is a proprietary system run by Apple, so that is open to that same criticism. The next option we have is AXCrypt, and this is an open source file level encryption, but only for Windows computers, and it allows you to encrypt an individual file or folder, and it can be very useful, one of the slightly older versions, if you wish to send a file using this and someone else has a Windows computer and has the program installed. VeraCrypt is an open source product, and it's a multi-platform encryption system, so it works across Windows computers, Macs and Linux, and it's built for full disk and container encryption. So it doesn't allow you to encrypt a file and send it, but it allows you to encrypt a file on the computer. So for example, you can create a special folder and then have that encrypted there to store all the research data. And all of these programs, I've put a link at the bottom because we have tutorials to help you with using these, talking you through actually using the products and how you can set up an encrypted folder to use them. So let's talk about a digital backup strategy now. So one of the most important things to ensure is that data are backed up. Now, although the universities typically back up data, it's important to understand what's being backed up, and if you're not using the university computers or you're housing some of the data yourself on your own computer, you need to consider a backup strategy for that. So here we think about the various topics which are in bold. For example, we'd start by thinking about what we wish to back up, whether it's all of the data and information on the computer or just some bits of that, or only the parts we change. Where should we store this backup? Should it be with the original copy? I wouldn't advise that, because then if you lose the original copy and it's on the same hard drive, you would potentially lose that one as well. So maybe have an external copy, a remote copy. What media will you use? So it used to be the case that we'd use things such as CDs and DVDs. These aren't used so much now. It's much more about USBs, external hard drives, and potentially and possibly cloud storage, though we will talk about some of the concerns around cloud storage in a minute. How often should this data be backed up? Should it be hourly, daily, weekly? Can you automate the process? So there's a lot of software now out there which allows you to automate. So for example, if we look at a Mac, it has something called Time Machine built into it, and it can automatically back up that machine for you and create like a complete duplicate of your computer. How long should you keep this data for? It's important to have a data retention policy. Universities all have one. How long will you store it for? And the other thing which is very important is to verify and recover. So you need to check that the data is backing up correctly. So you can use things called checksums, which we don't go into today because we don't have time. But again, there's tutorials on our website on how to use MD5 Summer to check on these kind of things. Backing up itself doesn't need to be expensive. You can buy very large drives now, 2 terabytes for £70, £80, and most of them all come with some form of software which can run on a Mac or a Windows computer. And you can also consider non-digital storage backing up as well, whether that be through paper. File sharing and collaborative environments. So often we find that file sharing is done by insecure email attachments. This should really try to be avoided. So there are other options. So we can look at virtual research environments which universities or your employer may run. There's things such as MS SharePoint. There might be a locally managed system of OwnCloud or Zen2 for sending files. So we have Zen2 here at Essex, so if we want to send a file we can, and if it's a sensitive file we would need to encrypt it before we place it into Zen2. You can send files securely that way. There's FTP. You could use physical media, so that could be a hard drive or a USB through the post. Again, if it's sensitive data, it should be encrypted to a good level. There are cloud storage, so I'm sure we've all heard of things such as Google Drive, Dropbox, Microsoft OneDrive, and iCloud. Again, you need to think about the data protection issues here, about where the data is being stored. Should personal data ever be placed in the cloud? Is that a good place for it? If you are going to use cloud for that kind of storage, are there securer options such as Mega, Spider Oak, Tresorit? Tresorit is based within the EU, so that would currently comply with the GDPR, whereas Spider Oak, when I last checked, was US based, and Mega is, I believe, New Zealand. So if you are going to use cloud storage, you need to assess these kind of risks and think about what data you're putting up there and how you're sharing that information. So I mentioned data disposal. So it's really important that equipment is disposed of properly at the end of a project. So the thing to remember here is if you reformat a hard drive, this isn't actually wiping the drive, it's just allowing that space to then have information written over. The best advice would be to physically destroy the hard drive if it had sensitive data on. There are some programs which I've put information to here on that claim that they can remove all traces of a file and overwrite the file numerous times, which will mean it's unrecoverable. Whether that is achievable in practice, if you have the correct software to gain information back, it is possible you might be able to. So one of the things that we would probably advise is just physically destroying that hard drive. That can be providing it to a specialist destruction service to do that for you. Okay, so our data management guidance. We have a lot of guidance online. We also have a publication, a book through Sage, and we provide a lot more training. We actually have an event coming up in Sheffield. It's a 2-day workshop. If you wish to go into these kind of issues in more detail, that's on the 28th and 29th of November. All these links will be, again, available when the slides are online, so you can click onto them. Tools and templates. I've included this slide so that you can have a look at some of the tools that we have to offer. So we have a model consent form, a survey consent form, transcription templates, confidentiality agreements, data lists, and a research data management costing tool, and all of the encryption tutorials that I talked about earlier. There's actually a full playlist of them, so if you wanted to go and watch them and see how easy it is to use the encryption programs we talked about. Keeping in contact with us, well, there's a JISC mailing list. You can also follow us on Twitter, UK Data Service. We also have a specific account which deals with research data management issues on Twitter, and that's UKDSRDM. We also have a Facebook page and a YouTube channel where many of the videos I mentioned earlier today are available online.
So thank you very much for everybody involved, and thank you for such stimulating questions, and we hope that we've been of some help for you. Good luck with everything. Bye-bye.